Hi, this is Marcos. Last episode, we've created a circular queue. Today, we'll change it to a dynamic circular queue. The main idea is to have a traditional circular queue, but whenever we need more space, we can expand it. Let's see, I will draw here so that we can understand what's the approach that we're gonna have. The main goal here in this situation is to expand the array. So imagine we have here a vector with some elements. Okay, so imagine that we have here number 1, number 2, number 3, number 4, number 5, and number 6. So the main goal is to allocate memory so that we can have here another space for more elements. Okay, so that's the main idea. In this situation, we have a queue that adapts its size as needed, but can reuse and use the space. So the idea is that every time that it expands, it will be near the optimum size of it. We will create a function that can shrink it when we want, but is not automatic. Okay, first, let's change some code in the circular queue. The first file that we're gonna change is the circularqueue.h. So let's see what we have here. We have here some constants that we use in the system. The first one is CQ size. So as it will be dynamic, I'm not gonna have a constant with the size. But one thing that is the main goal here is not to change a lot of the code. Okay, so I guess that we could implement more features or change the way we did some things, but I'm not going to do this because I think it's easier for you to understand what's going on if we change just a little bit. So first, let's get rid of the size here as a constant. In the variables, we're not gonna have a vector here, an array here. We're gonna have a pointer, so let's change it to a pointer so that we can allocate memory for it, and every time we need to expand it, we can expand the memory allocation. Okay, so let's create some other variables here. So extern size t. Size t is a kind of integer that has no sign, and we need to use it because this is used as a size of something. So size t is the best option. So CQ size, now it's a variable, and this variable I will explain later. This one that I'm gonna create here, I'm gonna do it here now just for the sake of not going back to the file, but I will explain later. CQ elements number. Okay, so CQ start, CQ end, boolean is empty. Okay, let's see here. We're gonna create some other prototypes here. The first one, void create size t initial size. This function is going to be used to create the queue, to allocate memory for it. It's very important now that we have a function to do that, because we're not gonna use array anymore. So to create it, we need to allocate memory. So let's have a function to do this, and it will be very easy to maintain the code. Okay, as we allocate, we need to deallocate memory. So destroy. This function is gonna destroy the allocation. So we have add, remove, let me see here, is full, array n, delete all, print q, and let's create some others. Void expand q, and void shrink q. Okay, I guess that's it in this file. Next, it will be in the circular queue.c that we're gonna implement everything we need. The first thing that I have to do is to include standard lib.h. This library it will have the functions to allocate memory, free memory, and so on, so we need them. So here, int pointer CQ, okay, it's not an array anymore, equal to new. New indicates that it's a new pointer. So this pointer is not gonna point to any place. Size t CQ size equal 0. Okay. Size t CQ elements number equals 0. So now I'm going to explain the difference of CQ size and CQ elements number. The idea is the size is the size of the memory allocated. If just in the sake of understanding, I will make a drawing now so that you can see what's the difference of CQ size and CQ elements number. CQ size is the size of allocated memory, and CQ elements number are the elements that are in this allocated memory. So let's see the drawing. Okay, imagine that you have this array here. So the size of the array, let's code this from here to here, is 1, 2, 3, 4, 5, 6, 7. So this is 7. So we have 7 spaces in the array that we can use. This is the CQ size. And from 1 to 3 are the element number. So we have here 3 elements. So we have this difference. One is the size of the memory allocated, and the other one is the effective size that we are using. Okay, continue. CQ start, CQ end, boolean is empty is true. Okay, so let's start developing the function. So create. So the create, you receive a size t, initial size. Okay. In this function, as we receive the initial size, we're gonna update the CQ size. CQ size is equal initial size. So now the size of the queue is the same as we initialize it, and we're gonna allocate memory. So how can we allocate memory? The command that I'm gonna use is malloc, the memory allocation. So let's see, CQ queue is equal to memory allocation, and what is the size of the memory? So we are gonna have a circular queue of integers. So I need to have the size of one integer, and then I multiply it by the initial size, and I have all the memory. So let's see, CQ size or initial size, they're the same, times size of int. So size of is a function that gives you the size of some variable type. Okay, so that's the idea. The malloc could return you one of two things. The first thing is new. It happens when there's no memory for the allocation. Just one, in the sake of understanding, sometimes you try to allocate memory and you don't have enough memory for that. But you see in some software that gives you the size of the memory and the free memory that you have the size of it. So why is not possible to allocate the memory? Because the memory needs to be contiguous, or in the block of memory that you are going to allocate, you have to have a free space with at least with that size so that you can allocate it. Okay, that's why you need to check. So if there's not memory or it's impossible to allocate, you're going to receive new or zero. It's the same in this case, that because we are using C. And or you're going to receive the address of it. So now we need to see the variable CQ as an integer to understand what I'm going to code here. In C, we have 0 as false and any other integer, positive or negative, doesn't matter, they are true. So if I receive a zero or a null, because there's no way to allocate memory, it needs to trigger a code to tell the user that's impossible and quit the program, because it's a fatal error. There's no way to continue. So how to do this? If not CQ kill, I will trigger the code. What's the idea here? If there is no memory, CQ, you will receive a null or a 0, and not 0 or not false is going to be true. That's why I'm negating the CQ. So if it's 0, or in looking at a Boolean type as false, not false is true, so this code is going to be executed. Or else it's going to continue. So if we have an error, I will print out of memory. Okay, and we're gonna exit the code with a negative number here, indicating the operating system that we had an error. Nowadays, it's not necessary to give the status as a negative or whatever, but in the past we used this to use a script to run our programs, and if we receive some errors, we could call some routines to solve it. Okay, that's why the exit needs a status. Okay, so that's it for the create. Let's code the destroy function. So the destroy function, you need to deallocate memory, and it's easy to do that. You just need to call free and pass the pointer for the memory. So CQ size. Okay. This is enough, but the CQ size, no. Oh, come on, CQQ. This is the pointer, not the other one. Okay, so this is necessary to tell the operating system to deallocate memory, to free memory. Okay, this is enough, but it's a good practice to pass new to this pointer. so that it's impossible to use it. So that's it. So is full is the same, array end is the same, but here's not the CQ size as a constant, but the CQ size as a variable. Okay. Delete all, add. So now we're gonna change a little bit here. Okay, so if I call this function and the CQ is equal to new, it indicates that the queue is not initialized. So print f queue not initialized. Okay, so I'm gonna give this error and exit it. So I'm gonna continue. So it's empty, it's full. Now I'm not gonna return false anymore, because if it's full, what are we going to do? It's easy. We're going to expand queue. So we are going to expand queue and return add value. So we're going to call again the function add, and we're going to receive a boolean that we're going to return there. So in this period of the code, everything is okay. So we expanded the queue and we added the value that was not possible to add. Okay. Else is empty equal false. CQ value, CQ and plus plus, if array end CQ start, and now CQ elements number plus plus. So how many elements are in the queue? So this variable is gonna have this information. Why? Because in the expand routine, we are gonna use it. So hold on that you will see. The remove, let me see here again. If CQ is equal to new, printf q not initialized. Okay, exit -1. Okay, let me see here the rest of the code. One thing that is very interesting is that we can use the pointer, the allocated memory, as an array. So why is it possible? Because all arrays, they are pointers, and all pointers are arrays. So you could interchange the same idea of them. Okay, so that's why we are changing very little in this kind of situation. You can see here in the add the same idea going on here. Okay. Okay, let me see if I have any different code here. If array end, if deleted all, and the CQ elements number -1. Okay. The print kill, I'm gonna use only this code here, CQ kill equal new. Let me copy this. It's the same. Okay. it's not initialized. I go CQ start, if it's empty, else print, and the code is the same here. Okay. And finally, we're gonna code the expand kill. Void expand kill. Okay. So let's see. Just for the debugging purpose, I'm gonna use this print here. Expanding \n. That's okay. So now, first, I will draw something here for you to understand what's going on. So let's see it. Okay, how are we going to expand the array? Let's suppose that I enter here number 1, 2, 3, 4, and 5. First, I need to allocate more memory for the elements. Then I'm gonna copy the number 1 to here, number 2 to here, and so on, so that I have 3, 4, and 5 here. And I have spaces for 1, 2, 3, 4, 5 more. So the idea is to do that. First, we allocate the new memory so that we need a new size of it. We have a rule that we're gonna expand by 5 elements. So we add in the size of this array here 5 more, allocate memory, copy the data, and we have here the CQ pointer. So CQ here, that is pointing here, and we need to point it to this other one prior to leave the function, and release this memory here, so that we are gonna free memory to give the memory back to the operating system, and this will be our new vector. Okay, so size t, new size equal CQ size plus 5. Okay, so we are gonna expand by 5 units. Every time that we need to expand it, we expand by 5. Int a pointer called the new q. So new q is an integer pointer pointing to new. Okay. And now we're going to allocate the memory for the new size. So new q is equal to alloc new size times size of int. Okay. If not new q, printf out of memory, new line, exit -1. Okay, and now we need to copy all the items that is in the old vector. So we start initializing I with 0, J with CQ start. Okay, so 2 variables here. I less than CQ size, I plus plus. Okay. new q I is equal to CQ J. You need to understand that the beginning of the queue could be in another place. So now J++, if array end of J. I'm not going to explain again. In the previous video, we have this the explanation of this function. So take a look at it. I will put a card here. J equal CQ array start. Okay. So now we'll free CQQ. I will point the queue to the new queue. The new queue is a local variable here, and CQQ is a global variable. So this is gonna stop existing and this will continue. So if I point to that place, I will continue using it. Okay, CQ start is the beginning of it because we rearranged the data. CQ end will be the CQ size. Okay, the CQ size will be the new size. Okay, that's it. So that's the code that is going to expand and copy all the elements of the array. So now let's have the shrink, void shrink q. So the idea of it is to eliminate spaces that are allocated that we're not going to use anymore. So size t, let's see some variables here. Size t new size. So imagine I have a queue of 50 elements, but in use I have only 4. So I need to get rid of the spaces that I'm not use anymore. So how do I know how many elements are for that I can have the new size? Simple. I have that variable CQ elements number. Every time that I add value, it increments element number, and every time that I remove a value, it will decrement elements number. So I have this variable here just for that. Okay, so int integer pointer new q equal to new. And now I'm gonna allocate new q is equal to alloc new size times size of int, okay, if not new q, print f out of memory new line, and exit -1. Okay, now I need to copy all elements. So for int I equals 0, j equal CQ start, I less than CQ element number I plus plus. Okay, so the new q I will be equal to CQQ j. and j++. Let's go to the next j. If array and j equal to CQ array start. Okay, so everybody was copied, so I can free the CQ kill, the old kill. The CQ kill will point for the new kill. It will point to the new kill. The CQ start is gonna be the beginning of the array. Okay. The CQ end will be the same because I got rid of every empty space, so it's the same as that we add to the last number, and now I'm in the beginning again. So I have a very little kill here. Okay, and I have the CQ size equal to new size. Okay, so that's it, the changes that are in the circular queue. Now we're gonna see the main.c. Let's see. We have here the constants that will be the same, but I will create another one. Menu shrink. Oops. Shrink. Okay. So I have the add, the remove, the shrink, the print, and the quit. Okay, the prototypes that I have, only menu. So the main. We need first create the queue with 5 elements for the beginning. Okay, so now I created a variable called option and another called value. So option, while option is not equal to quit, I'm gonna call the menu, and we have here switch option. The add, we're not going to change anything because this will never be called again. So I could remove it. Okay, so let's just comment here. I guess it's better than remove. Okay, the menu remove will be the same. And now, case, menu shrink. This is easy. Just call the shrink queue and break. Okay. The print is gonna be the same, and the quit, nothing to do it, invalid option. And that's it. And the last command it's a call I will do is calling the function destroy. So destroy is gonna destroy the queue to give back the memory for the operating system that's gonna use it for anything it needs. Okay, so let's change a little bit the menu. So we have the remove here. Let's duplicate this line. Shrink, menu, shrink. Okay, and that's it. That's it. Let's run it to see if it's gonna work. So let's see. Okay, we have here our program. So let's create elements in the same order, number 1, 2, 3, 4, 5, so that it's easier to see what's going on. So number 1, number 2, add 3, add 4, add 5. So let's print it. It's 4. We have 1, 2, 3, 4, 5. Okay, if we try to add any value here, it will expand. And as we had the print, it will print that is expanding. So let's add number 6. So expanding right here, 6 added to kill. So now if I print, we have 1, 2, 3, 4, 5, 6. Okay, it's working. So let's remove it. So remove, 1 was removed, remove, 2 was removed. If I print, 3, 4, 5, 6. So let's remember, we had an array with 5 places, with the size of 5. Then it expands to 10 places. And now I'm using just 4. So I could run shrink. So option 3, shrink, it shrunk. So let's print to see if everybody's there. Okay, 3, 4, 5, 6. If I add now any number, it needs to expand because we shrink it. So let's see. I will add number 7. Okay, here, expanding. Yo, it's working. So 7 added to kill. So if I try to print, it's there. Okay, very nice. So next episode, we will do the same using C++. Just to see the difference of the language, what the C++ language can give us to improve it, the idea of this. We'll see that we have some elements there that will make our life very easier than it's in here. Okay, so see ya and keep coding.